Good morning, learners. So today we want to look at the topic geometric and numeric patterns, different kinds of patterns in sequences. So these are the aims of the lesson. So by the end of this lesson, you should be able to investigate and extend patterns. So you should be able to know all this, and you should be able to describe and justify the general rules for observed relationships between numbers in your own words or in algebraic language. So these are the resources for you that can help you in this topic. So in this lesson, I will explain geometric and numeric pattern in the simplest terms possible. So terminologies and symbols, that is the first thing we'll be looking at. A number pattern is a pattern or a sequence in a series of numbers. This pattern generally establishes a common relationship between all numbers. A list of numbers which forms a pattern is called a sequence. Okay, so you should know. You can read all this for yourselves. It's self-explanatory. And here you have example of this. In this sequence, for example, the first number here is 3, the second number is 8, the third is 13, and the fourth number is 18. In other words, we can say the first term here is 3, the second term is 8, the third term is 13, and the fourth term is 18. Here, we get the numbers in this pattern by adding 5 to the previous number each time. So you can see, to get to 8 from 3, you need to add 5. If you add 5 to 8, it gives you 13. If you add 5 to 13, it gives 18. So here, the first term, the first number in this sequence will be 3. So it means A. The first term is always represented by A. At other times, it could be represented by T1. So this is T subscript to 1. So it is pronounced as T1. So in this sequence, our A or T1 equals 3. The fourth term equals 18, as you can see here. So T4 will be equal to 18. So this T stands for 10. Now, what is the difference between consecutive terms of a sequence? Okay, when the difference between consecutive terms of a sequence. Okay, let me read again. When the difference between consecutive terms of a sequence are the same, we say the difference is a constant. For example, let's understand what is meant by consecutive terms. So consecutive terms are terms that follow each other. In this case, 3 and 8 are consecutive terms. 8 and 13 are consecutive terms. Then 13 and 18 are consecutive terms. Now, excuse me. So if you look at the difference between any two consecutive terms here, it will be 5. For example, the difference between the second term and the first term will be 8 minus 3, which is equal to plus 5. The difference between the third term and the second term will be 13 minus 8. That will give us plus 5. And the difference between the fourth term and the third term would be 18 minus 13. That will give us 5. So you can see that the difference between any consecutive term here is a constant. So if we look at this, for example, this is another sequence. The first term of this sequence is 3. The second term is 1. The third term is -1. And the fourth term is -3. So if you look at the difference between any two consecutive terms, it will be -2. And I will show you why that is the case. So let's do this here. So we are looking at this sequence here. This sequence is what we're looking at. So we have 3, then 1, -1, and -3. So here, the first term is T1. And remember that T1 is also called A. The second term will be T2. The third term is T3. The fourth term is T4, right? So here, T1, the first term, which is also A, equals 3. The second term equals 1. The third term will be equal to -1, and the fourth term will be equal to -3. Now, if we want to find the difference between any two consecutive numbers or any two consecutive terms, it will be the higher term minus the smaller term. So it will be T2 minus T1, and this must be equal to T3 minus T2, and it must be equal to T4 minus T3. So that is the way you get the constant difference or the common difference. Here, T2 is 1. Then you have this minus sign, yeah? Then T1 is 3. And that will be equal to T3 here is -1. Then minus T2, which is also negative, which is 1. T2 is 1, right? Then remember this negative sign, and that should be equal to T4 is -3. Then you put this minus 3, then T3 is -1, so that will be -1. If we look at it, 1 minus 3 will give us -2. Then -1 is -2. Then here, these two negative form a positive. So we have -3 plus 1. That also gives us -2. So you can see from what we have done now that the difference between any two consecutive terms or the difference between any two consecutive terms will be -2. So this is a sequence, right? It is sequence because there is a common difference between any two consecutive terms. So let's look at this. Here we have 3 as the first term, 8 as the second term, 15 as the third term, and 25 as the fourth term. You would see that this pattern, this sequence is a bit tricky compared to the patterns we have seen so far. Here, you have to add 5 to get from 3 to 8. And now look at it, this is 8 and this is 15. So to get from 8 to 15, you have to add 7. And here you have 15 and 25. So here, actually, this 25 should be 24. So please correct it in your note. This 5 should not be there. It should be 24. So if you add 9 to these 15, then you get to 24. So what really happens here is that you add an odd number, right, to get from T1 to T2. And for you to get from T2 to T3, you have to add the next odd number. And for you to get from T3 to T4, you have to add the next odd number. So that is how this sequence was formed. Right, so here we add 5, then 7, then 9. So the difference is not a constant, right? The difference in this sequence is not a constant. Now, let's look at this sequence. We have 3, 6, 12, and 24. So in this case, to get to the next term or to get to the next number in the sequence, all you need to do is to multiply the previous term by 2, right? You multiply the previous term by 2 and you get the next term. So here, how did they do it? If you see this, the explanation here is that you take the higher term for any 2 consecutive numbers. So let me write that sequence again. We have 3, 6, 12, 24, and so on, right? To find the common ratio. This is a common ratio. It's different from common difference now. It's a common ratio. We will not go into the detail of that for the moment. We will discuss that in the future class, right? So here you can see that there is multiplicative effect here. You are not adding. It's not additive effect. It's multiplicative effect. In that case, to know the common ratio here, so what you need to do, or to know the constant difference here, all you need to do is to divide the higher term by the lower term for any 2 consecutive numbers. Then if you take 12 divided by 6, and if you take 24 divided by 12, so all these will be 2. All right, so that shows the relationship in this pattern. Now, let's look at this pattern here. Here we have 1, 2. We have 1, 1, 2, 3, 5. So here we have this. So to get to this third term, which is 2, you have to add the first 2 terms, right? And to get to this term, 3, to get to this 3, which is the fourth term, you need to add the 2 previous terms together, which is 1 plus 2. And to get to this fifth term, right, which is 5, you need to add the 2 previous terms together, which is 2 plus 3 to give 5. Okay. So let's look at this. The 10-term relationship in a sequence. Okay, one can identify a pattern or a relationship between consecutive terms in order to extend the pattern. A number pattern can be analyzed by focusing on the relationship between the consecutive terms as shown in the examples below. If you have 3, 7, 11, 15, and 19, starting with 3, 4 is added to get the next to get the next term each time. And let's look at this. We have 1, 2, 4, 7. Then we have 11, 16, and 22. So here, they are adding 1, 2, 3, right? So you are adding the next number, right, in order to get the next term. For example, to get from 1 to 2, you've got to add 1 to 1 to get to 2. Then to get from 2 to 4, you need to add the next number, which is 2. Then to get from 4 to 7, you need to add 3. To get from 7 to 11, you've got to add 4, and so on. So this is our activity, the first activity. So we have to walk through the following example that would explain how to go from one term to the next. Write the answers in your workbook. Only consult answers at the end of the lesson once you have completed it on your own. So I will work some examples for you, and you will have to work. You have to work the other examples. So the first sequence here, 1A, we have 2, then 5, then we have 8, we have 11, okay, then we have 14, 17, we have 20, then 23. So this question says that we should write the next 3 terms. Okay, we should write the next 3 number in each of the sequences below. Also explain in writing, in each case, how you figure out what the number should be. Okay, so this is an explanation for this. Here, to get from 2 to 5, you added 3, right? And to get from 5 to 8, you added 3. To get from 8 to 11, you added 3. So in any sequence, all you need is the first 3 terms. So the first 3 terms would give you the relationship that you need, right? So looking at the first 3 terms here, the first term, which is T1, which is also known as A. So T1, which is equal to A, is equal to 2 in this sequence. The T1 is the first term, the first number in that sequence. T2 equals 5. Then T3 equals 8, right? So here, if you look at the difference between T2 and T1, the difference will be 5 minus 2, and that gives us 3. If you look at the difference between the third term and the second term, that will be 8 minus 5, and that also gives 3. So here, 3 is the common difference, is a constant difference in this sequence. And remember, the question asks us to write the next 3 number in the sequence. So here we have this, and finally we have this. So to get this number, you have to add 3 to 23. That gives 26. The next term will be 26 plus 3, and that will be 29. And the next term will be 29 plus 3, which gives 32. All right, so that is the answer to that question. So let's look at the second one. So for that B, we have 4, 5, 8, 13. We have 20. This one is interesting. We have 29. Then we have 40. So we have to find the next 3 terms in this sequence. So now, let's consider the first 3 terms. This one, 4, 5, and 8. To get from 4 to 5, what did we do? We added 1, right? And to get from 5 to 8, we added 3. So here, the difference here will be the next odd number. So we are adding odd number each time, right? So let's investigate it. From here, from 5, the difference between 5 and 4 will be 1. 5 minus 4 is 1, right? Now the difference between 8 and 5 will be 3. And let me use this sign instead. The difference between 13 and 8 is 5. The difference between 13 and 20, 20 minus 13 will be 7. The difference between 29 and 20 will be 29 minus 20, and that gives you 9. The difference between 40 and 29 will be 40 minus 29, that will be 11, right? It means that the next one, if you look at this, it's the next odd number each time. So here, to get the next number, you have to add the next odd number after 11, that will be 13. So if you add 13 to 40, here you will have 53. And here you have the next odd number, which will be 15. So 15 plus 53, that will be 68. So you had the next odd number, which is 17. 17 plus 68, that gives 85. So that is how we complete that sequence. So let's look at another difficult one. So yeah, I will just do that number C again. I will do that number C, and you figure out the rest on your own. So it's just like a mind game, right? So you apply your mind to it and you get it. It won't always be the same sequence, right? So, but looking at the sequence, you should be able to know the trick to apply or the rules to apply in order to get your answer. So for that third sequence, you have 1, you have 2, you have 4, you have 8, you have 16, then you have 32, then you have 64, and they want you to give the next 3 numbers in the pattern. Here, to get from 1 to 2, right? You multiply 1 by 2, right? The same thing to get from 2 to 4, you multiply by 2. The same thing, to get from 4 to 8, you multiply 4 by 2. So each time you are multiplying the term by 2 to get to the next term. So here, the next term here will be 64 times 2, and that gives 128. The next term will be 128 times 2, and that will be 256. The next term will be 256 times 2. 256 times 2. Okay, let me just calculate this quickly. 256 plus 256. So that's 256 times 2. So here I have 2, then I have 1, then I have 5. So that will be 512. Yeah. Okay, so that is where we will end this video. So I will discuss the note further in future videos. Thank you for attending the class, and please just do the rest of the questions on your own from question D down to question H. All right, thank you.